Okay, morning everyone. Thanks for getting up this morning after rather fantastic party last night by MWR. I'm sure you had plenty of beers. My name's Andy Davis. I'm going to be talking about HDMI Ethernet Channel. And before I start, can I just have a quick show of hands in the audience? Before you saw the title of my talk, how many people had heard of HDMI Ethernet Channel? That's promising. Good. Okay, so I'm Research Director at NCC Group, and I've been looking at HDMI for a while. You might have seen a talk that I did previously at Black Hat on other elements of HDMI, but this talk is pretty much new today. Just a quick skim over the corporate slide. NCC Group, we've got offices all over the world, security consultancy and research driven. There's a couple of offices in North America that haven't been added to that. We recently acquired Matasano and Intrepidus Group. So that's the corporate stuff done. Let's get into the interesting stuff. So I'm sure plenty of you are going to be asking, why on earth am I talking about video interfaces? Well, it's the first thing we're going to cover off on the agenda. We'll then talk a bit about what HDMI as a technology brings to anything that supports it. And then we're going to dig a bit deeper into each of those protocols and have a look at the security implications of the presence of those protocols. There's a tool that I've created called CECSTeR, which I'll be giving you a demo of, and that tool's released today, so it'll be on our website for you to download and have a play with. In order to get to the kind of main part of the talk, the HDMI Ethernet channel stuff, I do need to cover over the CEC protocol and another protocol called CDC first to make it all kind of make sense. We'll then talk about what the implications specifically are of HDMI Ethernet channel in a corporate environment, and then we'll wrap up with some conclusions. So yeah, let's get this over at the start. Why on earth am I talking about video interfaces? Why should you be interested? Well, it all started for me when I was doing a research project looking at the BlackBerry Playbook. And I'd done quite a lot of work into USB security. And there were various teams looking at different elements of the Playbook, from application, software perspective. But it made sense with my USB background to have a look at the interfaces that were on there. So, looking at the interfaces on the bottom of a Playbook, the green one there is the USB interface, which is the one that I was primarily interested in. I thought, I've done quite a lot of work into this. I've got techniques for identifying bugs in USB stacks, so spent some time looking at that. Unfortunately for me, in this instance, Research in Motion had done a pretty good job at securing the USB stack, so didn't find anything particularly exciting there. But there were another couple of interfaces that I saw. Okay, the blue interface is a power connector. Three pins on that port. Not potentially very interesting. After a little bit of digging, there's nothing very clever going on there. We've just literally got power. But the red interface was a micro HDMI socket. I thought, that's interesting. Okay. Tablets these days are starting to more and more get HDMI ports on them. What on earth can I do with HDMI? Is it literally a case of plug in the monitor and it displays the information that's provided, or is there a bit more to it? Is it a bit more of an intelligent protocol? So I decided to investigate further. And the obvious first thing to think about HDMI is it's an output, right? Well, yes it is, but it's got a lot more to it that happens under the hood that you don't get to see about. So obviously video out and audio out, which is primarily what HDMI was designed for. I mentioned the presentation that I'd previously done at Black Hat. That was when I was talking about EDID, which is a protocol that advertises the capabilities of a display device. So when you plug something in to a VGA port or DVI or HDMI, it applies across the board. The monitor advertises its capabilities so that the video driver can configure itself. You see this when you plug in an external display into your laptop. On Windows, the screen will go blue while it has to think for a minute, and then it will display it on the monitor. At that point, there's a protocol exchange using EDID, so that the monitor can say, "Hey, video driver, these are the different resolutions that I support," for example. But with HDMI, there's a whole bunch of other protocols that have been developed to do other funky things. So there's a protocol called CEC. Before I go any further, there's a whole bunch of acronyms associated with this technology, so hopefully I'll expand them all as I go, but stop me if I'm talking about stuff where I haven't explained what the protocol is, because, yeah, it's very acronym heavy. So CEC, Consumer Electronics Control Protocol, is an input and an output. HDMI Ethernet Channel, the kind of primary driver for this talk, allows network data to be sent across HDMI. And then there's some encryption technologies like HDCP and DPCP for DisplayPort, which is kind of a similar version of technology to HDMI, but there are no licensing fees associated with DisplayPort. So as with any technology that you want to investigate, the first thing is you download the standard, right? Try and understand what on earth's going on, what all these acronyms mean. And there is a standard, there is a specification for HDMI. Unfortunately, it's only available to HDMI adopters who pay the license fee and sign up to all kinds of agreements that I didn't want to sign up to. Fortunately, the information that's in the standard is also available to anyone who's good at creatively Googling. So you can track this information down, but officially it's only available to HDMI adopters. There are some protocols that I'm not going to be talking about today. The EDID stuff that I've mentioned, I'm not going to talk about that in any detail because I've covered that before. TMDS, which is the protocol that actually transmits the video and audio data across HDMI. Again, I'm not going to talk about that. That doesn't kind of fit in or relate to HDMI Ethernet channel. The DDC bit there, DDC is the protocol that transmits the EDID protocol. So again, we won't talk about that. So the things that we are going to talk about, highlighted in green here: Consumer Electronics Control Protocol, CDC, the Capability Discovery and Control Protocol, and of course, HDMI Ethernet Channel. So CEC. Whenever I've spoken to people about HDMI, and the first kind of protocol that I started really playing with that did anything reasonably clever was CEC. And you mention CEC to people and they're like, what? I've never heard of that. Although most of the devices that are probably sitting in your home AV network support it. And of course, most of these vendors, as with a lot of these protocols, after they've been developed, the marketing team get their hands on it and they give it a brand name. So all these brand names that you can see on there, they are actually the CEC protocol. So I'm sure most of your Blu-ray players and home AV amps, that kind of thing, and plasma TVs will in some way or another support CEC in one flavor or another. And it's worth noting that although CEC has been defined in a standard, the standard has been left open enough so that people can implement their own vendor-specific additions to it. So looking at each of these, although the core functionality is pure CEC, each of the vendors have taken their own kind of twist on that and added extra little bits of functionality, which is where it might get interesting from a security perspective. So what's the purpose of CEC? Well, the general idea is as more and more pieces of home AV equipment were separated out, you buy your AV amp and your Blu-ray player, you might have various other devices, a home theatre PC, that kind of thing. You ended up with this whole selection of remotes, and people got fed up with losing the remote for the TV and the remote for this and the remote for that. So they thought, well, let's try and come up with a way that you can use one single remote to convey the intention of doing something. So, when you want to play a Blu-ray player, instead of having to go and fetch your TV remote and turn the TV on, and then turn your AV amp on and select it to the right channel, the right video channel and audio channel, then turn your Blu-ray player on, you want to be able to just hit play on the Blu-ray player, and everything just automatically works. And I'm sure many of you have been using this without realizing that it's happening. If you've got a scenario whereby you've got a Blu-ray disc in your player and it's switched off, and everything else in your environment is switched off on standby, and you hit play on the Blu-ray player, it will turn on that Blu-ray player, it will automatically turn on the TV, it will, if you've got an AV amp, it will turn that on, it will set it to the right channel, it will route the audio and the video to the right channel to go to the TV, and it will start playing the Blu-ray. And under the hood, that's the consumer electronics channel communicating between these different devices to ensure that everything happens in the correct order to play your Blu-ray. The architecture is like an inverted tree structure, which I'll show you an example of a bit later in the presentation. And it uses a one-wire bidirectional serial bus using the AV-Link protocol. You can have up to 10 AV devices connected within an HDMI topology. And as you plug in new devices, CEC automatically discovers what devices are there. And the way that CEC works, the way that it allocates the addresses is based on the type of device that you plug in, but I'll come on to that in a second. So there's a whole bunch of things that you can do by default with CEC, or when I say by default, that are documented in the standard. It's up to the different adopter of CEC as a protocol within their device as to how many or how few of these different CEC commands, or features as they're known in CEC, that they put into the device. So there's a whole bunch of different things on there. I won't read through them all, but you generally see subsets of these features available on devices depending on the type of device that they are. So for example, the BlackBerry Playbook supports CEC, but it doesn't have a timer programming function because that doesn't apply to the device. It's not relevant to that type of device, whereas that may relate to some kind of set-top box that's capable of recording TV, like a Skybox. So the protocol itself is a block-based protocol. Each block is 10 bits in length, and you've got 8 information bits, EOM, which is an end of message bit, and an acknowledgement bit. Specifically, at the beginning of each element of communication, you've got a header block. And I mentioned about the different addresses. You've got the source logical address and the destination logical address, so 4 bits for each, allowing you potentially up to 15. Now, I said that you can only have 10 devices. The reason for that is address 15 is always a broadcast address, and there are a couple of addresses that have been deemed as for future use. So within your header block, you've got your source logical address, destination logical address, and then after that, in a CEC message, you have an opcode block. So when I talked about those different features, each of the features has a specific opcode, and then there's an operand block where you specify the data that's associated with each feature, if data is appropriate. As I mentioned, there's a concept of broadcast addresses, so you've got either directed messages or broadcast messages that get sent to all the devices. And bear in mind that it's similar to a kind of a network hub type environment whereby all devices can see all the traffic associated with all hosts. In addition to these logical addresses, you've also got physical addresses, and they are in a dotted format and at first look appear to look like IP addresses, but forget about that concept straight away. It's absolutely nothing to do with IP addresses. It's just the way that's been structured. And I'll show you some diagrams of the way that CEC networks are plugged together, which will kind of give a better understanding of how those physical addresses are allocated. They literally are physical addresses. It's based on, which physical port within each device within this tree structure each of your CEC-enabled devices is connected to. So, having done a whole load of fuzzing on USB previously, my first thought was, okay, can we fuzz CEC? How easy is it going to be to communicate using this CEC protocol and, based on the standard, write some kind of fuzzer that will iterate through all the different features using those opcodes with a whole bunch of potentially malicious data within the operand field, and see if we can find some software flaws within CEC implementations. So how can we do this? Well, there's a number of different ways that you can talk to CEC. If you are into using the Arduino, an Arduino library has been written, and that little circuit there is one that somebody on the internet has designed. It's not something that I've put together, but you can use that to communicate with CEC using your Arduino. But that's quite limiting if you're using the Arduino to do it, because obviously you've got to put your fuzzer on the Arduino. And having done that before, when I wrote a fuzzer for EDID using the Arduino, it really does restrict what you can do. So there's a number of other things that you can do. There's two products which are essentially the same kind of thing. They're USB to CEC bridges, if you like, or interfaces. One from a company, Pulsate, and another, Rain Shadow Tech. And the reason that these devices are available is that currently the home theatre PC market needs the capability to interface with CEC, with HDMI. And although more and more you're seeing HDMI ports on new laptops and PCs, the software associated with these HDMI protocols just hasn't been adopted yet by any of the mainstream OS vendors. So it's still at this kind of like, oh yeah, you need to buy a bolt-on bit of kit and some extra software to enable that to happen. So I decided to use one of these. Where's my mouse pointer? Yeah, I decided to use this one. It's very easy to communicate with it. You can talk directly using a serial connection. It's got a very simple protocol that allows you to create serial commands to essentially describe the CEC command that you want to be generated on the HDMI side. So I wrote a tool called CECSTeR, Consumer Electronics Control Security Testing Resource. And the kind of driver behind that, as well as being able to fuzz the protocol, was just to understand, what kind of things can you do with this protocol. If you've got full control and you can actually try sending some of these commands, what kind of scenarios can we come up with? Because I've got a number of devices that support CEC at home, but they all pretty much support a limited subset. And if I can create my own, I can execute whatever CEC commands I like. The tool is live on our website. if you make a note of that link, you can download the tool. Obviously, you'll need to buy one of those CEC to USB bridges. They're about £40. It supports CEC and also CDC. I've mentioned CDC already, and we're going to be talking a bit more about that in a moment when we get onto the HDMI Ethernet channel stuff. But it allows you to do all the HDMI Ethernet channel stuff as well as the conventional CEC stuff. So you can capture traffic, you can sniff the traffic on the bus, send any arbitrary command, and of course fuzz the protocols. So I'm going to show you a quick demo of it. Initially I toyed with the idea of doing a live demo, but it would have just been pretty impractical because I would have needed to bring my plasma TV and Blu-ray player and a whole bunch of stuff. And although I have done it before, it's much easier to do a video. So that's what I'm going to do. Okay, so it's written in Python. And the first thing we're going to do is enumerate the devices on the bus. So it goes off. It's pretty slow because it's a serial-based protocol. And you can see there, I mentioned the different logical addresses are allocated to devices based on their device types. So therefore, it's enumerated the bus, and it can see that there is a device on logical address 4. And logical address 4 is always tied to a playback device. In this instance, that's actually CECSTeR itself. Logical address 5 is an audio system. In fact, before I go any further, let me just show how it's actually connected together. That would make sense, wouldn't it? This is what I'm actually looking at with CECSTeR in this demo. So these are all those devices that have just been enumerated. And I mentioned about the physical addresses. The TV is always physical address 0.0.0.0. And then as you go down each element within the tree structure, so like these are address 1 at the beginning and 2 at the beginning. So then things that are plugged into that are 1.1 and 1.2. So hopefully you can see that's the physical mapping of how it works out those physical addresses. So that's what we're actually looking at. So let's get back to the video. So it's enumerated those devices. Let's play. The next thing, we're going to select the target device. So by default, it had been the TV that was the target device. That's just the default when it starts up. But we've told it to be playback 2, because we want to find out what the device at playback 2 is. And we're now just scrolling through all those different CEC features. That slide that I showed you with all the different features, those features are the kind of high-level groups of CEC features that are available. Within those groups are specific commands that can be sent. All of that has been implemented within CECSTeR. So if I just choose one, which one do I choose? Okay, so give on-screen name. So what device is it at logical address 8? And you can see that it's come back. That's the actual data associated with the command that's been sent. So there's the command that I sent to say give on-screen name, which is opcode 46 with no operand data. And then the device has replied, set on-screen display name, which is opcode 50, and then a whole bunch of data, which is the name PlayStation 3. So when you plug devices at home into your plasma TV, and you'll see that it'll pop up normally in the top left-hand corner and say, oh yeah, you've just plugged in a PlayStation or Playbook or whatever. It's actually the CEC protocol that's communicating that information, and that's an example of what's going on there. And that's just one specific example of a command that you can send. There's a whole bunch of other commands that you can play with. I mentioned that you can also do the HDMI Ethernet channel stuff. All the commands that are required to do that are also within the tool. Later on in the presentation, I'm going to be going through and explaining what those commands actually do and what they mean. They're pretty meaningless at the moment. And of course, you can do some fuzzing. It's a pretty basic fuzzer at the moment, just as a kind of proof of concept of what can be achieved. But I intend to expand that because there's a lot more scope for things that you can potentially do here. For example, there's currently no concept of instrumentation to identify if the device has crashed. You just need to monitor that physically. So you can decide what your mutators are going to be, whether it's long strings, format strings, bit flipping. And at the moment, what it does is it actually iterates across the entire CEC protocol. So it will go through each of the opcodes and fuzz the operand data based on your mutators that you've chosen. So off it goes and it's fuzzing away. Okay, so that stopped. Another thing you can do is capture all the CEC data on the bus that's traversing the bus at the moment. So here's an example. Start the capture, and hopefully you'll start seeing some. Yeah, this is a whole bunch of data that's going across the bus between the different devices that are connected. And then finally, you've got a couple of view options, so you can decide whether you want. By default, it suppresses these things called polling messages. CEC uses this mechanism to constantly identify if any devices have been unplugged, so it sends these polling messages, but there's tons and tons of those, so you wouldn't really want to display them in a packet capture. So by default, those are off, but you can turn those on if you want. And also the raw data associated with each of those commands, you can decide whether or not you want to see that. So there we go, that's that. Let's get back to this. Okay. So what are the fuzz results? Well, nothing groundbreaking, unfortunately. There are a few results. The big problem is that, as I said, there's not really a huge amount of CEC functionality that's been adopted yet by a lot of these devices, and I've only got a limited subset of devices that I'm prepared to potentially break. So I'm hoping that people are going to download the tool and have a play with it and actually find some stuff themselves. If you're looking at physical devices, you know, if you've got a nice shiny Blu-ray player, do you really want to start fuzzing it and potentially brick it? Probably not. So there's the dilemma there. I did fuzz my Blu-ray player and did get some random lockups, which resulted in me needing to reboot the thing, and but nothing that could be conclusively linked to specific CEC commands that were sent. Extremely limited CEC functionality in the BlackBerry Playbook version that I was looking at. There were no results there. The most interesting thing was a home theatre PC called XBMC, and they actually recommend that you use the other USB CEC adapter, the one that's that I didn't use for CECSTeR, and managed to create a permanent DOS and that. So I bricked it, which is great, but because I bricked it, I'm not entirely sure quite how I bricked it, and I don't really want to brick another one because I have to buy a new one. So it's clearly generating traffic that's causing, you know, unexpected circumstances within the protocol. So hopefully people will be braver than me and play with it and try and break some of their devices. But there are some quite interesting commands that can be sent using the tool. I mentioned the fact that CEC is open to interpretation by the vendors. So there is this vendor command, which means you can basically send anything you like in there. So I've seen that a few times within different products. So they send it, and you can send all kinds of random data that relates specifically to that product. You also saw the set on-screen display string and on-screen display name. Obviously, you've got the whole processing of strings, displaying of strings type bugs that might exist there. And then there's also the CDC command, which I'm going to come on to next. So, onto the main thing, HDMI Ethernet channel. What's the design rationale behind this? Why on earth are people trying to put Ethernet down HDMI? Well, basically, as far as I can see, it's all about keeping your lounge tidy, right? People started, first of all, connecting TVs to the internet so that you could watch YouTube on your TV in the lounge. And you needed, of course, to plug in an Ethernet cable into the back of your TV so you could connect to your broadband and get to the internet. And people were also plugging in devices via HDMI cables to their TV. And as the devices became more fully featured and more complicated, those devices wanted the capability to download firmware updates, download extra content off the internet to make them look prettier. So they wanted to be connected to the internet as well. So you'd need an extra Ethernet connection to plug into the back of your Blu-ray player. And somebody thought, well, this is going to make my lounge look really messy with all these extra cables. I've got enough cables as it is. So someone thought, okay, right, well, let's use HDMI. Everything's connected together with HDMI. Why don't we just put Ethernet over that? Sounds like a good idea. So it was introduced in HDMI version 1.4, which is the one prior to the current standard. And consolidates the video, the audio, and data streams into a single cable. And it uses this CDC protocol to control those Ethernet channels. So, capability, discovery, and control. This is used to discover potential Ethernet channels, so it needs to be able to work out which devices support HDMI Ethernet in order to work out how to route all this stuff. And it's worth bearing in mind that when you want consumers to start connecting devices together in a network, they just want to plug it all together and it'll work. They're not going to know about preventing routing loops and making sure that different devices are able to connect to other devices with the network. They just want to plug it in and make sure that it's connected to the internet. So it's been made as plug and play as possible, so it all just happens seamlessly. It's also used to activate and deactivate the channels, communicate the status, and CDC messages are actually a CEC message, which is why I talked about CEC first. CDC messages are just a CEC message with a specific opcode. So the operand data for a CDC message is going to be processed as CDC if the opcode is F8. And whereas with CEC you could send directed messages, all CDC messages are sent to the broadcast address. Okay, so what does it look like? So you've got the CEC header, the opcode F8 that I talked about. You then have to specify the physical address of the device that's sending this message. You've then got a CDC opcode, which talks about the CDC command, and then a CDC operand. Okay, so what sort of things does CDC want to do? So obviously it needs to understand what interfaces on the different devices within the network are capable of connecting via Ethernet, the ability to change those states, and also this set state adjacent allows the configuration of other interfaces on the same device, not just the one that's being configured by the command. So you can configure multiple interfaces simultaneously. And when I get, it's a bit of a busy slide this, it's more to kind of highlight the fact that there's lots and lots of different combinations within a given connected network of potential HDMI Ethernet channels within that setup. So depending on the different capabilities of the different interfaces on each device, you may have all these different permutations of HDMI networks within a given connected system. So there are a number of different states associated with HDMI Ethernet channel. PHEC, which is a potential channel. So this is basically if you have any interface on your device that has a physical capability of talking HDMI Ethernet channel, then that's considered part of a PHEC. VHEC, the verified HDMI Ethernet channel, is after a CDC command has actually been sent to query that device using this HEC discover message, and it confirms that yes, it does have the capability to talk HDMI Ethernet channel. And then finally, you've got AHEC, which is an active channel. So after it's decided which of the devices within the network are capable of talking HDMI Ethernet channel, it activates the channels between those different devices, and AHECs are when the HEC set state command has been used to actually create a channel, and therefore networking is then active, and those devices can then communicate via the root device, the TV, which basically acts as a switch to the internet. Now, as I mentioned, you can't really expect home users who this has initially been aimed at to understand about things like network loops. They just want to plug it all together, and I'm sure as a result of having all their kit plugged in under the TV, they're probably going to try and generate routing loops inadvertently. So it uses the rapid spanning tree protocol to counter any routing loops that happen. So if you've got a routing loop, it'll disable one of the links, and then if the other link that allowed access to the other device is then broken, then the one that was disabled initially is re-enabled. Simple kind of routing loop prevention stuff. It also has a concept of queue control, so prioritizing traffic based on traffic type using the 3-bit priority field in VLAN tags. So obviously if you've got a very bandwidth intensive protocol like video, then you're going to want that to have a higher priority than maybe just kind of file browsing, that kind of thing. So it has the capability to do that too. And hopefully at this point you're thinking this is all very interesting, but you're also probably thinking, hang on, what's this got to do with what I do as my day job? You know, how is this in any way relevant outside someone's lounge? I'm never going to be pen testing a home AV network, right? Well, as you've probably noticed, all the new laptops and PCs that are coming out now have got HDMI connectors on them. And very soon, protocols such as CEC, HEC, CDC are going to become adopted by the major operating systems. And the driver behind that is home theatre PCs. More and more people are setting up their own home theatre PCs rather than buying a commercial alternative. And in order for home theatre PCs to integrate seamlessly within AV networks, you need to be able to talk these protocols. And currently you need to buy one of these separate little interfaces. So as more and more PCs have HDMI ports on the motherboard, people are going to start developing the drivers to talk the protocols by default. So you don't need to buy extra kit, and you don't need to install extra software. Also, let's say you found a bug in an HDMI-enabled TV. Big deal. But as I'm sure you've all seen, plasma TVs, LCD TVs, are now becoming part of the corporate infrastructure. Most boardrooms these days have got a big flat screen TV, and quite often they're connected to the corporate infrastructure so that they can do firmware updates, or so that they can do other kind of funky collaborative video conferencing type activities with them. And incidentally, there was a presentation recently at Usenix that talked about a bug in the Samsung Smart TV whereby you could circumvent the way that it was checking whether applications that were downloaded to it were signed or not, and basically exploit the TV. So, people are exploiting TVs and demoing this kind of stuff. So HDMI is just going to be another route into attacking them. It's just an element of their attack surface. So how else might HDMI actually affect corporate users? Well, there's a couple of different scenarios. First risk, corporate boundary breach. I talked about a boardroom scenario. I'm sure all of you have been into a meeting room whereby you come in with your laptop, there's a video cable on the boardroom table, you plug that into your laptop to do a presentation. You might be going to a customer's site to do a debrief from a pen test, or maybe doing some kind of sales presentation. So they are trusting you by allowing you to connect your machine to a piece of their infrastructure. Now, normally that's a plasma TV, or it might be a projector, but more and more those are becoming network connected to the corporate infrastructure. The projectors that we're seeing are becoming more and more network connected so that people can do remote presentations from their desk maybe, or maybe from another part of the world. So if you come along and connect your laptop to the HDMI cable, an HDMI Ethernet channel is enabled on those ports, and when we get to the stage where it's been supported by the major operating systems, which I personally think is only a year or so away, you could have the scenario where just by plugging your laptop into the HDMI port to do your presentation, you're all of a sudden part of their corporate network. And the obvious risks associated with that, potential exfiltration of data or infiltration of malware, obviously things that people don't want to happen to their corporate network. And unless people are aware of these kind of technologies and the potential implications, this kind of stuff can just be happening behind the scenes, because purely as a result of the way that the protocol has been developed to just work in this plug-and-play fashion. Another scenario, endpoint protection circumvention. So more and more people are using endpoint protection software to stop people plugging devices into their corporate PCs, like USB-based devices, to stop people taking data away on memory sticks, that kind of thing. But using HDMI Ethernet channel, you might be able to plug in your tablet into your corporate laptop and establish an Ethernet channel between those devices. And unless your endpoint protection circumvention software is HDMI Ethernet channel aware, which they're certainly not at the moment, it's not going to be able to detect that kind of thing. Okay, and another risk, you could basically create your own unauthorized network connected via a corporate PC that's all connected together using HDMI Ethernet channel. So essentially the way that it works is just like in the home AV setup. So instead of your TV being the switch that essentially nats all the traffic from behind it out onto the internet, your corporate PC could be acting as a router to nat all the traffic from your private HDMI connected network onto your corporate network. And if on the corporate network you've got network intrusion detection systems and network monitoring tools, You might see extra traffic that's originating from that corporate laptop, but you won't have any visibility of the individual devices that are connected via HDMI Ethernet channel behind it. So, have I tested HDMI Ethernet channel? No. There's a very good reason why. As I said, it's a relatively new standard. The standard itself was developed about 18 months ago, I think. And the only device that I can find commercially that supports HEC is a Blu-ray player from a company called T&A. There it is, very nice shiny thing. It costs £6,000. I haven't got £6,000 to spend on a device that I might brick. So it is new. It's coming. I'm sure it will start to be adopted in other devices and in the major operating systems, but it's not quite there yet. But when it does arrive, CECSTeR will be able to test it. Another thing that I kind of threw into the mix here isn't related to HDMI Ethernet channel, but it's talking about keyboard loggers. Anyone remember hardware-based keyboard loggers? There was this kind of big storm around the fact that, you know, cleaners were going around inserting these little devices between the keyboards and PCs in corporate environments, and various high-profile cases of data that was stolen from banks and the like. Well, someone's created an HDMI video logger called Video Ghost. Now, this is pretty scary stuff. 7-year battery life. It'll just sit there behind your PC. 2 gigs worth of storage, and it just takes screenshots of everything that happens over your HDMI and stores them, and you can then go back and recover them via USB. So potentially a lot more powerful than a keyboard logger. Okay, so some conclusions. I've talked a lot about the kind of seamless functionality that users really expect these days. You can kind of understand that in the kind of home AV environment. Home users just want things to work, regardless of what potential security risks they might introduce. They just want stuff to work. And that's kind of the driver behind some of these technologies. The fact that it just needs to work when you plug it in seamlessly. HDMI Ethernet channel, initially designed to save the number of wires you have in your lounge, might end up having major impact on corporate security, depending on who actually takes note of where the protocol is and where it's been implemented and how much it's being used in the corporate world. It's still really, really new and largely unsupported. So as well as checking your PCs for hardware key loggers, also you should now be looking for video loggers connected. Basically anything plugged in to the back of your PCs in a corporate environment that you don't know about. It's probably doing something dodgy. But before long, all the laptops are going to have HDMI ports, and they'll probably eventually support all of the protocols that I've talked about today. So has anyone got any questions?
Just a question on the physical interface. A question on the physical interface. Is the Ethernet over separate twisted pair to the, our digital video stream? I.e., could you make a tap and tap it off as we know Ethernet?
Potentially, yes. Yeah.
Okay, interesting. So
it's not integrated with the video and audio in any way. It is actually going over physical cables within physical wires within the HDMI cable.
Okay, so a hardware block would be a piece of cake, in other words. All right, thanks.
Yeah. Okay, thanks very much.